Okay, here's another question. This time we're calculating percentage yield. Okay, so before you attempt this and you haven't had a look at my reacting masses video, check that out first because you need to understand how to calculate reacting masses before you can work out percentage yields. Now let's look at the question. It says if in the reaction below 32 grams of C2H6 produces 44 grams of CO2, what is the percentage yield? Now a lot of students make a common mistake. They see 32 grams and they see 44. They think let's divide 32 by 44 and multiply by 100 to get the percentage. That is not correct. Now I will show you step by step how to get this right. So the first thing to do is the equation you need to know. So percentage yield equals actual yield divided by theoretical yield multiplied by 100. This equals the percentage yield. Now it's important to understand what that means. Now actual, you need to work out, generally questions give you the actual yield. So in this equation we're saying that 32 grams of C2H6 produced 44 grams of CO2. So what's produced is the actual, meaning what you actually got. Okay, so that's the actual yield. So in this situation we have the actual, we need the theoretical, so we can calculate the percentage yield. Now this goes to a simple calculation with reacting masses. So what I'm going to do is, let's write the equation down here one more time. So it's 2 moles of C2H6 plus 7 oxygen produces 4 CO2 plus 6 moles of H2O. Let's write down what we have. So in this reaction we have 32 grams of C2H6. So let's put down 32, and it gives us what's actually been produced here, which is 44. We're not going to put that down because we need to work out what we could get in theory if everything went to plan 100%. So we don't know this value here, so let's get the theoretical yield, which we call the reacting masses equation. Okay, so what I'm going to do now is we've got 32, we need to get the mass of C2H6. We know carbon is 12, there's 2 of them, so that's 24 plus 6 hydrogens, that makes 30. Okay, so if we were to divide 32 by 30, this would equal the number of moles. Remember this equation? The number of moles equals mass over molecular mass. So 32 divided by 30 equals 1.066 recurring. So how would you say 1.067 moles? Okay. Now we need to find out the actual mass. So we look at CO2. Let's get the molecular formula for CO2. We know carbon is 12 and oxygen is 16. There's 2 oxygens, so 16 times 2 is 32 plus the 12 will give you 44. We don't know the mass, let's call that M. Moles. Now here's where the mole ratio comes in. So it's a 2 to 4 ratio. So that means it's double basically, right? So 1.6067 needs to be multiplied by 2 to get the moles. So the moles here will be 2.133. So how do we get the mass? We do 2.133 moles of that's carbon dioxide, by the way, multiplied by 44, and this would equal 93.87 grams. Okay, now we've got the theoretical yield. Okay, so we had the actual, we've got the theoretical. Now let's put them together. So actual was 44 grams. So 44, divide that by 93.87 equals, let's get that first. So 44 divided by 93.87 equals 0.47. I'm just rounding this up, okay? Multiply that by 100 would equal 47%. That's not a great percentage yield. So the actual product we're getting is 47%. The rest is going to waste, okay? So that's something which you should understand from this calculation. So just to sum up, we look at the question, we see what we actually produce, that is the actual yield. You put that into the equation, you need to calculate theoretical yield, you use the reactant masses equation, and also factor in the actual mole ratios, and calculate the mass, then divide actual by theoretical, multiply by 100, you get 47%. I hope that was helpful, guys. See you in my next video.